question 6. Let's solve the system of equations so that we can find the ordered pair that represents the solution to the system. So, what is the best method to use in this case to solve the system? Personally, I will prefer elimination. And why is that? Because I can actually easily make these coefficients right here line up and match up. That way, we can combine these equations and get rid of the y. And how can I do that? Well, I can multiply the bottom equation by 2. So I get a 4y. Rather, a minus 4y, right? So 3x times 2 is 6x. Negative 2y times 2 is negative 4y. And negative 25 times 2 is negative 50. Okay. The top equation, I'll just rewrite it right here. Now look at this. Negative 4y plus 4y. If we add them, they're going to cancel out. 4y plus negative 4y is 0. One very common mistake here, I'll mention this again. If we were to subtract it, if we had 4y minus negative 4y, we would end up with 8y. That's not what we want. We want a 0. So that's why we're going to add it, or add the 4y to the negative 4y in this case. So it always depends on these signals right here. So since they are opposite signals, we want to add the two equations. So without further ado, 5x plus 6x is 11x. Those canceled out. 17 plus negative 50 is negative 33. So we have 11x equals negative 33. So I can divide both sides by 11. And x will be equal to negative 33 over 11, negative 3. Great. Now we just need to solve for y. So let me plug in the negative 3 for x right here. So we get 3 times negative 3 minus 2y equals negative 25. 3 times negative 3 is negative 9 minus 2y equals negative 25. Then I can add a 9 to both sides of the equation. Negative 2y will be equal to negative 25 plus 9, negative 16. Then we can divide both sides by negative 2y. So y is equal to negative 16 over negative 2, which is 8. Great, so we want the answer in x comma y format. So that's just negative 3 comma 8, because x is negative 3, y is 8. So the answer is A. Negative 3 comma 8. That's it.